In this video, I want to bring up a really important issue with triangles. And in order to demonstrate this, I've got two triangles here. As you can see, they are quite different. They have similar dimensions in terms of their side lengths. So they both have side lengths of 8 centimeters and 4 centimeters. But this one is an acute triangle with an angle here of 60 degrees, and this is an obtuse triangle with an angle here of 120 degrees. In order to demonstrate the issue that can come up, let's use our formula, which we know is area equals a half times A times B times sine C, to calculate the area of these two triangles. So for this first triangle over here, the area is going to be a half times 8 times 4 times sine of 60. So I'm going to put that into my calculator. A half times 8 times 4 times sine 60. And that gives me 13.86. 13.86 centimeters squared. Now this one over here, the area equals a half times 8 times 4 times sine of 120. So if I put that into my calculator, a half times 8 times 4 times sine of 120, and it gives me also 13.86 centimeters squared. So these two triangles, which look very different, one is acute and one is obtuse, they have exactly the same area. And that is because of a very important thing that you should know about these trigonometric ratios we've been dealing with, sine, cos, and tan. And let's just focus on the sine ratio for now. Sine of theta will actually give you, and you can test this with your calculator, sine of theta will give you the exact same result as if you do sine of 180 minus theta. Sine theta and sine of 180 minus theta are exactly the same thing. Now, it's not really within our course to go into understanding why this is the case, but if you're interested, then come and ask me, and I'm happy to go into it because I think it's important for general understanding, but I'm not going to go through it in the video. The important thing to know is that here, so sine of 60 and sine of 120 are then exactly the same thing, which is why these two give you the same answer. That means that for every triangle there's an inbuilt ambiguity into it because of that result with the angles. So when we're doing these area questions, if I have the side lengths and the angle in between, then I can calculate the area of the triangle exactly. But if I get given just the area and the side lengths, and I'm asked to calculate the angle, then as you can see here, there's sometimes more than one possible answer. So if this question had been, there is a triangle with an area of 13.86 centimeters, one side length is 8, one side length is 4 centimeters, calculate the angle in between, there would have been two possible answers. So let's see an example of that. Let's say I get this question. A triangle has an area of 20 centimeters squared. If two of its sides are 12 centimeters and 9 centimeters, find the angle in between. So I know that my formula is A equals half AB sine C, and I'm told that the area is 20 centimeters squared, so that means 20 equals a half times A is 12 centimeters, B is 9 centimeters, and I'm looking for the angle in between. So let's rearrange this a little bit so that we can try and isolate C. So first I'm going to move this half over to the other side by multiplying both sides of the equation by 2. So I get 40 equals 12 times 9 times sine C. Then I'm going to divide both sides of the equation by 12 times 9. So I get 40 divided by 12, and then I'm going to divide that by 9. So I've divided by 12 and then divided by 9. So I've just put those two steps into one, and I get that 0.3704, let's go to 4 decimal places, equals sine C. So here I've got a ratio and I'm looking for the angle. So I need to go backwards through the sine machine, or I need to use the inverse sine. So sine inverse of 0.3704, that's going to give me C. So if I put that straight into my calculator, if I do the inverse sine of this answer, it gives me 21.7 degrees. However, we need to bear this in mind. This triangle is ambiguous. We're not actually sure. It could look like this. It could be an acute triangle with an angle of 21.7 degrees. Or it could be an obtuse triangle where C could also be 180 minus 21.7, which would equal 158.3. So it could be 21.7 degrees, or it could be 158.3 degrees. So if you ever get a question where it's giving you an area and asking you to work out the angle, then you need to look, either you need to give both answers, or the question itself will give you a clue. So for example, it might have said here, an acute triangle. And if it had done that, if it had said an acute triangle has an area of 20 centimeters squared, then I know I'm looking for an acute angle, one that's less than 90 degrees. So the answer would be 21.7. So that's an important factor to bear in mind when doing these questions, remembering that triangles can be ambiguous and that sine of theta, this is the important result, that sine of theta equals sine of 180 minus theta.